Okay, so while it is starting, let me have a little quick questions from Java, which is going to be related to Hadoop now. So what is the serialization in Java? What is the serialization in Java? What is the serialization in Java? Anisha?
Serialization is the passing of object through a network in the form of bytes.
Passing through. That is not a serialization actually. That is the usage of the serialization.
Uh, Converting of objects into bytes.
Yeah. So a process of converting your objects into byte stream is a serialization. Is a serialization. So why we need to convert into bytes? Why we need to convert into byte stream? If you when you want to transfer an object from one machine to another machine, why we need to transfer an object? Let's assume that there are two applications are running in two different JVMs and two different machines. When I want to transfer an object from one machine, one application to another application, based on this object, that will do some other operations. Okay, let me open. Let me open our. Okay, serialization. A process of converting object into byte stream, object state into byte stream. Okay, object states into byte stream. What is object states? What is object states? What is object behavior? How will you represent object state in the code? How will you represent object behavior in the code? So object states are variables in a variables in a instance variables in a object, like you say id, name, salary, something. So object behavior means methods, get salary kind of methods, right? This is object state and object behavior. The serialization is the process of converting your object states into byte string. We already talked about the streaming. We already not streaming. We already talked about the serialization. If you guys can go back and see the Java videos. What is this? Why I need to do? Why I need to convert into byte string? Let's assume that I have an application running on this machine, a client application. You can say client application, and there is some server application here. So client application, it's a server application. So the client will produce some objects, which is an employee object, let's say EMP object. This object will go to this machine here, this application will go and talk to some database, something it will do. Okay, so to execute some operation in this other application, I need an object. So that object I need to transfer from the client application. That object I need to transfer from the client application. So this object, to pass this object through a network, the object cannot travel through a network. It is not at all possible. What we need to do, we need to convert this object into byte string. So we need to convert into byte stream and then we need to transfer to this application. So that's called serialization. The process of converting your object into byte stream is called a serialization. And what this will do, this guy will deserialize it the reverse way. He will take the byte stream and will create an object, then he will do some operations from here. Because Java application understands the objects. And here this is Java application. It understands the object. But only network cannot take the objects, right? So to do that, what we will do, there is something called serializable. There is some interface called serializable interface is there. What is the serializable interface? Can anyone tell me? What is the serializable interface? Anisha, Harika, Kishore, Sai, Venkat, Venkat Nikesh, Sai, Venkat Nikesh, you guys are mainly. Harika, you. What is the serializable? Serializable is an interface. Serializable in an interface. I can say it is a marker interface. What is a marker interface? The interface does not contain any method and anything. Empty interface. Sir, if it is empty interface, what is the use of it? Now here I'm passing employee object, right? So all the objects are by default not serializable. All the objects. Okay, they're not by default serializable. So when I create an employee object, I want to transfer this object through a network. I need to specify some special behavior apart from its own behaviors. I need to specify some special behavior for this employee object saying that it can be serializable. Can be serializable. It can be serializable. It means this object can be converted into byte stream. This object can be converted into byte stream. So we need to do it, right? So how we will do it? So we have something called serializable interface. We need to implement this interface in our employee class. Implements blah 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 we need to do. When I do this, I no need to override any method because this serializable interface does not have anything. Okay, now then what it is doing? So it does not have any method. So how it is doing? So as soon as we implemented this serializable interface, your class has a special functionality or special behavior where its objects can be serializable. How it is? Your serializable interface is telling to a JVM saying that this guy is implemented me. So, so this guy has a special behavior. So even though he is not doing anything, because of this guy as a part of his class implemented this interface, now this employee is eligible for converting into byte stream. I have something called department. Let's assume that case, which is not, it's not implemented as serializable. I have something called department object, which is not part of the serializable interface. Now this cannot be serializable. You cannot try. Even though if you try, it will give some exception. Unable to serialize or something. Some exception it will throw. I didn't remember the can't serialize. I think serializable not support or something. So that exception it will throw. But my employee is extended implemented serializable interface. It can be done. Okay. So why we need to do a serialization? One is transfer through a network. Two is when you want to store object state into permanent persistent storage. What is a persistent storage? Permanently storing it into files or somewhere. When you want to store this object employee ID, employee name, salary into persistent storage into files, storage into file, we will do serialization. So these objects will be created in the RAM. These objects will be processed in the RAM. All applications will be running in the RAM. Nothing will store in the hard disk when your application is running. So but the code will be there. The code is different from your actual object, right? The code is different from your application, right? So if you want to load a object state into persistent storage, or you want to transfer object state into through network, we will use a serialization. We will do a serialization. Here in Hadoop also, if you see, the data is transferring through one node to another node in the RPC form, the form of RPC, remote procedure call. How remote procedure call? How remote procedure call? What is the remote procedure call? RPC is a lightweight protocol which will carry a small information. It means the information is going from one machine to another machine. Are you guys there with me?
Yes, Surya.
So the RPC is transferring some information from one machine to other machine. So it's a lightweight, it will pass the message. So that message, when it's passing the message, this message has going through a network. So when it is the message is going through a network, it means it should serializable. Correct? That message should be serializable. Now, how this message is converting into serializable, converting to byte stream? Hadoop Hadoop is using its own serializing mechanism. It's using it's a serializing mechanism that is called writable. That is called writable. If you guys remember, there is something we have seen: int writable, long writable, right? Those are all objects. It means that type of data is by default serializable. Okay, it is using something called writable interface. What is this interface? It is not a marker interface. It has a two methods. It has a two methods. One is write method. It will take okay. It has two methods. One is write method. Another one is read fields method. Write method is for serializing. Read method is for deserializing. One second, guys. Someone is knocking my door. Yeah, sorry guys, I'm back. So, so this writable is has two methods. One is the write method, and writable interface has two methods. One is write and read fields method. So what is this method does? It is doing a serializing here with the write method. It is doing a deserializing with the read fields method. Okay, why Hadoop is using its own Why? Hadoop is using its own serializing. Anyway, the Java has a serialization already, right? So Hadoop framework came from the Java itself, right? The Hadoop framework it same came from the Java, but we developed using Java only. Why can't Hadoop uses Java serialization and Java data types? Java serialization and Java data types. Why? This is an important entry question, guys. Try to understand this. Okay. Why not Java serialization? Why it is going its own serialization? Why Java serialization or why Java data types? Both are same, guys. Okay. So we know that Hadoop required all our object type data types, all object type data types like wrapper class type of data types. Even Java has a wrapper class type of data types like integer. We have seen integer, float, double, character. These are all object type data types. They are by default serializable. They are by default serializable. So why Java Hadoop is not using Java serialization? Because when you do a Java serialization, when you do a Java serialization, along with a serialization information, it will produce so much of information. Let's say I have something called int I equal to 16. It will, after doing a serialization of this, it will produce so much of information about a class, about the type of the class, about the type of the variable. All the information will be generated and small information will be your int. This much information will be generated by your Java serialization. But when it comes to Hadoop serialization, so Hadoop uses very small technique. There is internal this own algorithm. So it will just convert whatever is required. It will not generate unnecessary information. If it has unnecessary information, what will happen? So this much information has to travel through a network to send only some simple value. This much information I have to transfer through a network, which is a burden on the network. So in the Hadoop environment, network is the more important, right? So we need to pass, we should not have anywhere network congestion, should not be having any traffic, right? We should just pass an object, just pass an information. That should be like that. So that's the reason that is the reason your Java serialization is not using in a Hadoop. Okay. So for this, guys, we have a very nice document in the drive. I have kept the document for in the drive for you guys. I hope everyone has access to this. If anyone of you does not have access, please let me know. Hadoop solutions. Okay. And in that you have something called nodes. In that you have something called Mapreduce. In that you have something called nodes. In this Mapreduce nodes, this is the one. You can download it. Okay. This, if you go little down, it's loading actually. Yeah. Writable and writable comparable. You have a very nice notes in information here. Why RPC? The RPC message should be very compact and very fast and extensive. Compact means very less information should be to reduce the network bandwidth. Okay, so the Java serialization is not compact. Okay, that is the reason we are not using Java serialization. And data your RPCs required a compact and no, a fast transformation. So that is the reason we are using a writable interface, where the writable interface has the write and read fields method. And internally I'll show you the source code, no, not to worry about it, how it will work. So the actual serialization mechanism is nothing but converting your into byte stream, right? This is what the serialization, if you remember our Java code, what we have written, we have taken output stream, and we have taken file output stream we have taken, because that time we have written into the file, we didn't pass through a network. So serialization is nothing but you have transferring your whole data through whole object. Okay, there is something called here uh, deserialization is also whole data, so you don't have something like a choosy. Let's say here when I want to serialize, let's say I want to serialize employee. The employee has a ID, employee has a name, employee has a salary. So now I want to serialize only employee ID, salary. I don't want to serialize employee name, or I want to serialize only employee ID, comma, name. So my other application required only ID and name. So it does not require other things. So when it required, so when I go with the normal serialization, what I will do, whole object I have to do. You may say that, sir, I have something called externalization where I can do that. So that's also one of the reason I'm telling. So where I cannot choose here, I cannot choose. But when it comes to the your writable interface, you can choose field wise. You can choose ID can be serialized and name can be serialized, or you don't want the name, only ID can be serialized. But when it comes to Hadoop Java serialization, you have to serialize complete object. Complete object. That's what we say. Output stream dot write and will pass the object. So if you see the document here, it also clearly shows the same thing. Look at here, the serializable interface. The serialize method, what it will do, it will take the complete object, your data output stream object, complete data output stream object will take and will serialize. And deserialization also it will do the same, right? But I don't want to take the complete no object. I want to choosy. I want to choosy. So how will I do choosy? By using your write and read fields in this writable interface. Okay. Okay, I hope everyone is clear about this. Any doubts? So this is a more important interview question, guys. I'm going to repeat one more time. Why Hadoop is not using Java serialization or Java data types? The reason is Java serialization produces the more information than your Hadoop. Hadoop required a compact and fast type of byte stream. So where Java serialization is not doing that. Java serialization produces so much of information, version information, class information, the object information, along with your actual data. So that will take more network bandwidth, so it is not preferable to take the Java serialization. And the other reason is, in the Java serialization you have to do a serialization of a complete object instead of choosing the fields. Okay, instead of choosing the fields. So that's the reason we are not going with the writable we are not going with the Java serialization. So your Hadoop has two interfaces, as I said, writable, and there is something called writable comparable. I hope everyone knows about the comparable. Everyone knows about the comparable, right? So there is an interface called writable comparable. No space, guys. It's a single word. It's a single word. Extends writable interface, comma, comparable interface. So this does not have its own any methods. Does not have its own method. It's not have. It is taking two methods from the writable. Two methods are like a write and read fields method. One method from the comparable interface. One method from the comparable interface. So it has the two methods. One is the write read fields. This has a compare to method. If you guys remember, we have discussed more about this. It has a compare to method. So now whenever you extend your writable comparable interface in your Hadoop, writable comparable, if you whenever extend this, we have to override all these three methods. When you use only writable, if you use only writable, you have to use only write and read fields method. Okay, all Hadoop data types are writable comparable. All Hadoop data types are writable comparable. Is everyone is clear about this point? Is everyone is clear about this point? Any doubts? Any doubts? Anisha, Harika,
No,
Masood,
Veera, it's clear.
Kishore, Masood, Rakesh, Sai, Vaishnavi. Okay.
No doubts, Vira.
So now I'm going to show you how we will write our own data type. So I think everyone is understand about the writable, comparable. If you are not, please go through this document. The document has a very nice details. All the information has been detailedly explained here. I recommend you to go through this document. The document is available in the drive. If anyone does not have access to this drive, please let me know. So writable and writable comparable, and there is something called comparator, writable comparator also there. So at this time being, we don't need it. Okay, so there is something called raw comparator. The raw comparator information also is written here. The raw comparator, how that compare raw comparator, you can also go and look at have information. Normally, let me explain what is a raw comparator. Okay, let me raw comparator. Raw comparator. So normally we know that what is a comparator, right? As similar as your comparable, right? Raw comparator. So what that will do, that will compare two objects, Ravi employee object and Veera employee object. It will compare these two objects, correct? It will compare these two objects, right? Objects only it will compare. But when it comes to the raw comparator, what raw comparator will do, let's assume that this has been serialized. Serialized will be always numbers, guys. It will be in like it will be in byte numbers, right? Byte streams, right? So Veera also did it. Now your raw comparator is eligible for is able to compare the serialized objects. It can compare the serialized object. It can compare the bytes of objects. Your raw comparator internally uses byte stream to compare. I mean array of byte. So what it will do, it will be having the starting position, ending position. It will be having starting position, ending position. So what is the size of it? What is what is the size of it? Length of it, I can say. So it will compare this information by using without deserializing. So we no need to deserialize. When you want to compare, when you want to compare, you have to deserialize. When you want to compare two objects, you have to do deserialize. If you do deserialize, you are putting some efforts to deserialize. So if you use the raw comparator, internally it uses the raw comparator, so it is reducing the overhead of the deserializing. It is reducing the overhead of the deserializing. That is the advantage of the raw comparator. This is also one of the interview question, guys. So what is the raw comparator? So if you are showing more experience on the Mapreduce, they may chances where they can ask you what is the raw comparator. What is a raw comparator? What is a writable comparable? Why Hadoop using its own serialization mechanism instead of Java mechanism? So these are all little important thing. Okay, so this bytes to compare the raw comparator information, this byte it no need to deserialize it, and normal comparator uses the deserializes. Okay, let's go back and see our Java things. Hadoop, little small program here. Here, why I'm explaining about a writable comparable. So you clearly understand here, guys. You guys need to answer me now. So it is a writable comparable. Let me write one more time here. I have a two interfaces. I have a two interfaces. One is writable. Other one is writable comparable as well. Writable and comparable as well. Now it is a writable and it is a comparable. So in our MapReduce, we have a K1 V1 and give to K2 V2. The final output will be K3 V3. Right? It will take this, it will give this. It will take this, it will give this. Right? It will take it will take K1 V1, it will give the K2 V2. So your reduce method also will take K1 V1, it will give the K2 V2. Sorry, K2 V2 it will take K3 V3, it will give. Now I have a key and I have a value. Key and value. So what has to be, so which one has to be writable, which one has to be writable comparable, based on the our algorithm we will specify. But with the MapReduce algorithm, always, so why we will go with the comparable? Always, whenever you're seeing the comparable in the previous examples on Java or somewhere, comparable or comparator, why we will use? For the sorting purpose. The sorting purpose. So the sort is happening based on what? Key. So always your key will be key data type. I'm talking about key data type will be writable comparable. Writable and comparable, because so their mapper output K2 V2 will go through short and shuffle. There it will, this will be, this is going through, there is something called sort. Correct? There is something called sort. We are doing a sort here. Guys, if you remember my map phase, in the map phase, after the short and shuffle phase, here it is taking K1 V1, right? Here in sort and shuffle phase, it is sorting the keys, right? It is sorting the keys, right? This sort is doing keys by using quick sort algorithm. I'll show you all these things. Quick sort algorithm. So it means your keys are getting sorted. By default, your framework is sorting the keys. By default, your framework is sorting the keys. So whenever you are going to write your own data type, we have to make sure if it is a key, we should go with a writable comparable. If it is not a key, if it is a value, you can go and write the this one. Key must be, I'm talking about K2. K2 must be writable comparable. Why? Because your framework knows only sorting the keys. It doesn't know how to sort the values. That we will see by using other technique called secondary sorting. We will talk about that later. Right? Here, so this writable comparable, so why I have brought to your in front of you, the thing is that there may be a chance some places the key K2 is not always predefined data types. Like my, as of now what we have seen K2, it can be text. The K2 we have seen a text, it can be long writable, it can be any predefined data type. K2, right? So suppose I want my K2 has to be my own data type. K2 has to be my own data type. My own data type. So let's say Vira custom data type. Let's say it's a Vira K2. I'm just taking an example, guys. So in this case, what I need to do, I need to write a class Vira K2 extends, sorry, implements. It's an interface. Implements writable comparable. And in this class, whatever the variables I'm going to declare, I have to take care of them. Like what was the logic, based on the logic. What is my data type? Vira K2 is taken care. What type of objects? Let's assume that it has something else. Okay. Along with them, I have to override write method. I have to override read fields method, and I have to override compare to method as well. So if I override these three methods, now my Vira K2 is happily go as a K2. Happily go as a K2. So now, so I'm going to give you a scenario. So in that scenario, we need our custom data type. We need our custom data type. So for the custom data types, to create a custom data types, we are going to use a writable comparable. So today's topic was, started is custom data types. So to bring to you, to make you aware of the custom data types, so we should know what is a serialization, we should know what is a writable, we should know what is a writable comparable. So that's the reason I brought first serialization on these things, then I'm going to show you custom data types in a Hadoop. How to write the custom data types. How to write a custom data type in Hadoop. So why should I write the custom data types? So to explain that, let me take a simple scenario, simple example. Based on that, I will explain this here. Okay, I have a data like this. Storing large data. Mapreduce is for process large data and so on. Okay, now, okay, before explaining this, everyone open your browser. Everyone open browser. Everyone open the browser. Let me open myself as well. Go to Google. Go to Google. So here I'm showing you something interesting. Go to Google. Just type for Hadoop. So immediately it is showing some recommendations for me. Hadoop tutorial, Hadoop training, Hadoop entry questions, Hadoop architecture, Hadoop certification. First it will show what was my history, what I have searched for. Later it will start showing you the recommendations. Right? So it will show like this, right? So it is for Hadoop. Let's check for Java. Java Wiki, Java 7 API, Java tutorials. It means the combination is whenever you type Java, the next immediate word is first it look for your cache if it is not there, and next immediately most of the people are searching for Java tutorial. How the count is coming? How it is coming in the first place? How Java entry questions are coming in second place? How Java world is coming third place? How it is coming? So that I am going to show you. So you just type how it is coming. How to. See here how this is my Kerberos setup or something which is my local. This is so many people are searching for how to. After how immediate is how to. After how immediately how to. See here the more combination they're using how then to. So what does it mean? What does it mean? So as soon as the people are started searching for on a word, it is able to find out what is the next combination. How it is they are finding this combination? Because based on the count, these two together occurs. Based on the count, the together occurs. Let's say how to is there, how is there. Now how is came 10 times, it came 100 times. So based on this count, it's kind of word count only. So it's a kind of count, they're bringing this into first place and they're bringing it into second place. Right, based on the count. So now what is my requirement is here also I want to bring two word combination. I want to bring two words combination. These two words has to come. I want to find out along with the Hadoop which word is coming more. Along with the Hadoop which word is coming more, right? And along with this word which word is coming more. So this kind of combination I need to do. Okay, it is as similar as your word count program only. So as similar as your word count program only, but we need two words, word 1 and word 2. Two words we need, and my k2 will be, see guys, here count is like this. My k2 will be word combination of word 1 word 2. Okay, my k2 will be word 1 word 2. This is a combination. This is a combination, and it will become an object. It is an object. This is my k2. My v2 is nothing but as similar as 1 only. Okay, so as similar as 1 only. So this object, I'll name it something called bigram. Okay, so now my output of the mapper should be ctx dot write of Bigram, comma 1. It should be my output. My output is an object, custom data type object, custom data type object. So how to write a program for this, we will discuss tomorrow. Okay, how to write a program for this, we will discuss tomorrow. And by the time I am giving you an assignment, this as an assignment, please please do some research on this, how to write a program, and you can also refer my code and try to understand it. Anyway, we'll be discussing tomorrow in detail. Okay, any doubts?